So that is when you think about what kind of data to acquire. So this confounding cannot be just because of primary or secondary data. Even in primary data you will get confounding effects because of ethical issues, like you do not want to have the image of a person, okay. You do not want to store any personal sensitive information other than this thing. You may not want to monitor their activities. So I have to just go by questionnaire. Let us say he walked, he ran, he walked and said I ran for this much time, but my but let us say I have a device for measuring the cardiac, whether he is good. No, this is something which we are proposing to the government called Cardiac India, where we say, like, let us say, hey, I will look at monitor patients and then using the apps and then prescribe them that they should walk this much steps. Now suppose I am not allowed to monitor their activity, then what can I do? I have to only ask questionnaire. Now will you say I am lazy? No, you will enter, oh, you may have done 2000 steps, but then in your mind it may appear like 10,000, you will say 10,000, totally confounded, right. Now even after doing 10,000 steps you are sick, that cannot be the case, but your data says that because of the confounding effects, right. So many times even the ethics will hinder to actually do a proper study, okay, that has to be kept in mind, the confounding effects. So when it comes to data, the data itself what you collect is of two types, qualitative and quantitative, okay. So we have qualitative data and quantitative data. How do you deal with qualitative data? Quantitative data is easy, numerical scale. How do you deal with qualitative data? Let us say I toss a coin, the outcome is what? Is it qualitative or quantitative? Quantitative. What is the quantity here? Is it a number? Outcome is a number. It is head or tail. Is it quantitative? It is a numeric. Is it a numeric? It is not numeric. It is outcome has nothing to do with numeric. It is a qualitative output, right, head or tail. Let us say hair color, let us say 5 categories are there. Is it qualitative or quantitative? Qualitative, right. Hair color, if I say black, red, blah blah blah, then it becomes brown, then it becomes qualitative data. All of these are qualitative data sets. Many a times you will get qualitative data sets. Now how do I deal with qualitative data sets? Remember, you will have both qualitative and quantitative data sets, right. So you have this continuous data which is like temperature, let us say you have body temperature, your blood sugar levels, your pressure levels, blood pressure levels, you will have all these parameters that are measured, right, heart rate, activity, heart BPM, beats per minute, whatever the basics, right, those are all quantitative. But then qualitative becomes your age is still quantitative. So your ethnicity like Asian, Caucasian, etc. And then your whether male or female. So there are certain aspects, gender, other things that becomes qualitative, and there are quantitative aspects. Now these two have to be merged together to analyze. Agreed? Yes or no? Because there are variables, these are also very important variables for analysis. So how do you deal with qualitative data? How do you deal with qualitative data? How? Take a simple example, head or a tail, what do you do? Assign a variable that takes number 1 when it is head, number 2 it is, or number 0 it is tail, very simple. So most of the time, so that is our strength, even if it is qualitative we convert them into quantitative data, and these will become discrete variables, these will become discrete variables, they will not be continuous, whereas your temperature is a continuous variable, like I could have 38.90 98.4, 98.5, 98.6, or depending upon the sensor you use, I could have 98.4444 whatever, right. So we convert this qualitative data also into quantitative for analysis using what we call it as random variables. We will come to that, okay. So qualitative to quantitative using mapped using random variables, okay. So the qualitative data itself is two types, dichotomic, polynomic, okay, that is pretty simple. Dichotomic, yes or no kind of answers, polynomic is like good, bad, ugly, etc. So multiple classes, multiple categories, two categories, dichotomic is typically two and polynomic is multiple categories, okay. And then quantitative data itself also is two types, discrete or continuous. So give an example of discrete quantitative data, discrete quantitative data, some biomedical example, biomedical variable, yes, beats per minute is quantitative, but it is discrete. You cannot have 72.1 beats per minute, right. You say 72, 73, 60, etc., right. And of course many variables are discrete, even blood pressure, when you measure you do not give a 62.1 or 72.1, you give 80, 20, 120 or 84, 125, some range, some whole numbers, right. You do not want, you voluntarily do not want that accuracy also, right, because you know yourself that there are so much measurement errors that you can only do a whole number, right. Of course heart rate, it's either heart rate beats per minute, that means heart will beat only every minute or what, it is a continuous quantity. You for every minute, is it going to beat 70 consistently every minute? No, right. So and you may skip counting, there are measurement errors, right. So it is a typically we make it into a whole number. So many a times we know that there are enough measurement errors and you do not need that accuracy, so it becomes discrete. Give me an example of a continuous, ECG, EMG, well it is good to have that continuous, okay. In reality when you think much, by strictly or rigorously, there is nothing called continuous. Why? So you have what is known as A to D converters. So can any instrument measure with 20 digit accuracy? Have you seen? Your thermometer records with 20-degree accuracy, but why not the underlying temperature you think is not having 20 digit? You could have 100 digits or 200 digits, something may be 0, something may be non-zero, but you have voluntarily discretized the amplitudes, that we call it as quantized. Have you heard of this term called quantization? Meaning your output amplitudes are also sliced, it is not going to be continuous. Why? It again does not make sense for the purpose of accuracy. If somebody says my true value is 91.33334353 after analyzing 10 samples, does it even make sense? That fellow does not understand head or tail, useless, period, right. You have 10 samples and you have 20 digit accuracy, does it make sense? So for all practical purposes our amplitude is also quantized. So in a sense continuous, truly continuous does not exist, okay. The only thing is in discrete you have kind of integer, close to integer outputs, in continuous it could have decimal points. That is an easiest way to and a practical way to think about discrete or continuous, okay. In continuous, when we mean by continuous is there are decimal points, okay, that is a practical way to think it. Theoretically you can say continuous means theoretically that continuous does not exist in reality at all. Okay. Theoretically there is no continuous data at all, because your sample is also discrete samples, discretized amplitude. So we call it as discrete in time and amplitude, that is what it actually is. Okay. Discrete in time and amplitude. Digital is like you make it to 0 1, that is digital, but it is at least what we have is discrete in time and amplitude. The only practical distinction is, say discrete versus continuous, the first thing is typically like a what I call integers, kind of integers. The continuous space is like with decimals. Both of them in a sense have only restricted sample space. Truly infinite sample space does not exist, because your instrument is not going to give you that accuracy to have a infinite sample space. Okay. So the continuous random variables will have, or the continuous data will have a bigger sample space. What do I mean by sample space? What is sample space? Sample space, we learned about sample, I am calling now sample space. What is it? There are a set of values that can be taken by a data point. What is the value that can be taken by this sample? That is the sample space, right. We will formally define it, but truly continuous does not exist. One has to understand this is with a bigger this thing. So now this is very important. Before I conclude, I have 5 minutes. So let us talk about variables and parameters. It becomes very, in fact even industry, many of them don't understand the distinction between variable and parameter. First we will distinguish variable and parameter and then go to it. Give me an example of parameter and variables. Measuring temperature in this room, what is a variable? Temperature is a variable, okay, because it is going to vary and I am interested in controlling the temperature in this room, that is a variable of interest. What are the parameters? Humidity is a parameter, humidity is also varying. Why is it a parameter? Varying. Humidity is varying, that is a variable that is of not interest to me, which affects my variable of interest. So this is where confusion can come in. So there are many variables itself. Temperature is one variable, but what else are the other variables? Humidity is a variable. What else that could influence temperature? Our breathing rate is a variable, right. You cannot control it. It is a variable which affects the temperature. Then what are the parameters? Volume, dimensions of the room. This is fixed. Dimensions of the room is fixed. Then what is the difference between a parameter and a constant? You have parameters, variables, and so what is constant then? So in this room what is constant? When you talk about temperature measurement, what is something constant? If you say room dimension is parameter, so if you think, do you think room dimension is a constant? Yes. To whom is it? To whom it is a constant? Okay. So let me give this example and then I will let you ponder upon. So go look at difference between variable, parameter and constant thoroughly. I will give you this example. Suppose you are buying an AC, you are buying AC, okay. What are the things you will think in mind? Whether you want to buy a 1 ton, 1.5 ton, 2 ton or more, right, the cooling effect etc, right. So now you have decided, IIT has decided to put a room in this AC in this room. Look, there are multiple vents, right, multiple 4 of them, of course only one is running, that is a different story, okay, given the temperature climate it is okay. So now how do I decide? Let us say in my room they have to put an AC, will they put a 2 ton? 0.9 ton is enough actually. How did they do? Given these parameters, the room dimensions, what is the best level? If I change the parameter, so as a designer For me room is a parameter, room dimensions are parameter. As a person who decides to, for me it is a parameter. Why? I change the parameters and then I simulate and see what is the best. Suppose I want to do, try to see what is the best AC that can be installed, best ton AC that can be installed in this room for certain specifications. One of the key specification is tons, right? Whether it is 1 ton, 1.5 ton or 2 ton, I simulate this room and then if I change the dimensions, of course the quantity of AC will change, right? The tonnage of AC will change. So in that sense it is a parameter. I am not going to change it continuously. For a given set, this is the best AC, that is what I want to arrive at. So for me room dimensions are parameters when I am deciding. As a user everything is constant for me, only temperature, I do not even carry about variables are constant because everything is fixed, you are just using it. As a designer or as a person who makes a decision to change, those things become a parameter, okay. And what becomes a constant for him? Availability of 50 hertz power. He does not go and change 50 hertz to 60 hertz or 100 hertz. 50 hertz power is there, power supply 230 volt will come, 230 volt 50 hertz 230 volt RMS will come, that is all. Is that a parameter for him? No. For whom is it a parameter? When I am designing the machine, right? We have to say whether you understand. Some companies will say you do not need voltage, you do not need a voltage regulator. Why? They would have did the normal variation and said look 229 also mine will run, 231 also it will run. For a certain amount of fluctuations which is normally seen in the country, my equipment will not get damaged. So for him when he simulates, he would have done for it as a parameter. 230 what is the performance, 229, it is not a continuous variable again, he cannot do it for 1 volt and then say it will run. The normal fluctuation he would have covered. For him it is a parameter. For the other person it is a constant because he does not care about power. He has given me this AC. This AC if it requires 50 volt whatever nonsense 230 volt it will run. Then my only concern is how to choose the tonnage. For me parameter is different and variable is different. For that guy who is designing an AC, room is not even a constant for him, room is not even a concern for him, room size. Why should he be worried? He has been asked to do 1 ton AC, to manufacture 1 ton AC. So he will manufacture 1 ton AC, he does not care about the room dimensions etc. He will only care about manufacturing 1 ton AC with certain specs, which output flow rate, what is the cooling effect, how do I measure the cooling effect, what power does it run, if I fluctuate what will happen, does it require a regulator or not, is it better to have, those are the kind of questions. So depending upon the person and interest, parameters, constants, variables will change. For him humidity is not a concern, for you humidity is a concern. As a user you are worried about humidity. Why? You will change the settings of AC depending upon humidity, depending upon number of people in this room. If I have 50 more, I cannot have this, should have more. For me that is a variable of interest. For the other guy who is manufacturing AC, he does not care, or who is choosing your AC depending upon the room dimension, he will not even worry. This is the AC. Now if more number of people are there, you reduce the temperature, that is the thing you make, right. This is like a designer of a room. So suppose I call an architect, what is the variable for architect? Constant. The plot size is constant, he cannot buy more, everything else is a variable for him. He can do multiple sizes, multiple things. Now when you get to the engineer, what is it? Design is fixed, so rooms dimensions are fixed, he works on different things. So depending upon the nature of the problem and who is addressing it, variables, constants and parameters will keep changing, okay. So keep that in mind, these are 3. Variable as such is a variable, for any person it is a variable, okay. Parameters depends, okay, you do it for fixed set of parameters etc. Parameters differ, okay. And constants something of interest, something not of interest. For me 50 volt is not even 230 volt is not even interest constant. Why would I worry when I operate AC? Somebody told me that it will operate, I am assuming it is there. For a designer that is very important. Okay. So that is how these three things are. I would require you to go through more on this because there is a lot of clarity. You yourself understand, right? Have you ever been able to distinguish between variable and a parameter? Constant you will say okay, constant is easy, but the moment you ask variable and parameter you will start, is this a variable, or for safer side we will say parameter. Many times for safer side you will ask one thing, and only one thing something of interest is a variable, rest of it you make it as a parameter, but that is not true. Okay. So please go through this variable parameter constant. Next class we will meet, tomorrow's class. Thank you folks.